Here I will go over the limit laws and give an example. To define the limit laws, I will need the following limits. The limit of a function f of x at the point c is equal to L, and the limit of function g of x as x goes to c is equal to m. So the first rule deals with sum, so it's called sum rule. If we're taking a limit of two functions that are added to each other, then we can sort of distribute the limit in, so we'll have that it's equal to limit as x goes to c of f of x and the limit of g of x. We know that the limit of f of x at c is L and the limit of g of x at c is m. So that's the sum rule. Then similarly, we have the difference rule. Here we take a limit of a difference of two functions. This is equivalent to taking limit of f of x as x goes to c minus limit of g of x as x goes to c. And we know what those limits are, which is just going to be L minus m. Then we have the product rule. If we take a limit of a product of two functions, f of x times g of x, then it's going to be equivalent to multiplying the limits of x by the limit of g. So if we can apply the limit individual to f of x and g of x, and we'll get that the limit is equal to L times m. Next we have a constant multiple rule. It states that the limit as x goes to c of k times f of x, where k is some constant, is just going to be equal to k times limit of x goes to c of f of x, which is just equal to k times L. So it's very similar to the product rule, where we kind of distribute the limits in. It's just a limit of a constant will be equal to that constant. So we get this rule. Then the next is the quotient rule. Here we take the limit of a quotient of two functions, which is just going to be equal to limit as x goes to c of f of x divided by limit as x goes to c of g of x, which is going to be equal to L over m. Note that m cannot equal to 0 since we can't divide by 0. And last, we have the power rule. Here we take the limit of our function f of x as it's taken to some power, say r over s. It's going to be equivalent to limit of as x goes to c of f of x to the power r over s, which is going to be equal to L r over s. These rules combined tell us that in most cases we can find the limit of a function through substitution. Now I will give an example of this. So for example, if limit as x goes to 2 of minus x squared plus 5x minus 2, and working it out, here I will use the sum rule, and I'll distribute in my limit into the parentheses. So I'll have limit as x over goes to 2 of minus x squared plus limit as x goes to 2 of 5 times x minus limit as x goes to 2 of 2. Okay, so for the first term, we can view it as minus 1 times x squared. So we have the constant multiple rule. So we have minus 1 times limit x goes to 2 of x squared plus, I use the constant multiple rule again. I have here 5 times limit x goes to 2 of x. And a limit of a constant will be equal to that constant. So we have minus 2. I can, for the first term, I can further use power rule. So I'll have limit x goes to 2 of x squared plus 5 times, so now I can apply my limit. So limit of x is, we can use substitution and get that it's equal to 2. We have minus 2. And then similarly here, we can say that limit of x as x goes to 2 is going to be equal to 2 squared plus 5 times 2 minus 2, which is just going to be equal to minus 4 plus 10 minus 2, which is going to be equal to 4. I would like to illustrate that we could have solved this problem simply using substitution. And that's what I was saying, that if in most cases, unless we're dealing with a rational function whose denominator is 0, these rules allow us to freely use method of substitution when finding limits. So I'll just give an example. We could have just substituted 2 right away, and we would get 2 squared plus 5 times 2 minus 2, which is going to be 4 as well.